Well, welcome to another recording of Science Physics 20. I'm going to try to use this kind of strange pad to write in my answers while I solve problems. It may work, it may not, we'll see. It'll make my poor handwriting even worse. Anyways, today I want to go over the dynamics review sheet because I can't be in class. So I think I did question 1 and then question 2. Now I wanted to do a third question, which was, if you have an astronaut in a space chute standing on a scale inside a rocket and the acceleration of the rocket is going in some direction. In this case, the question was a 65 kilogram astronaut and the rocket was accelerating downward. So probably the easiest way to do that, as usual, we like to write in our variables. So we're given that the mass of the astronaut is 65 kilograms. Oh yeah, my writing's beautiful. And we had an acceleration downwards, so we had an acceleration downwards of 10.3 meters per second squared. And then we had to know what was the apparent weight of the person. Probably the best way to do that is to look at the force of normal. For force of normal, in this case, you could do the net force of the which would take into the applied force of the rocket and the force of gravity, but we can derive a simpler formula which I've shown you in class. Just take the mass and multiply it against the difference of the accelerations. I think Landon was the first one to actually come across that on his own, and the methodology works really, really well. So if we take this way, we say the mass of the person is 65 kilograms. Wow, this is tough to look at the screen and write down here. And the acceleration we had was a minus 10.3, and then we were subtracting the force of gravity, 9.81. Because we're subtracting a negative number, we're going to end up adding it. So you're going to end up multiplying 65 by what will be minus whatever the difference is here. I don't have it calculated and I don't want to take your video time. But if you do that, 65 multiplied by, it's got to be minus a little bit. We're going to get a negative number, and we're going to get minus 31.85 newtons. So that's the force of normal, so their apparent weight, which is the inverse of that, right? Apparent weight is the inverse of the force of normal, which means their apparent weight is about 31.85 newtons. I think the significant digits in this case was only 3, so you would have to round that to 31.9 newtons. So that's the answer.